Good morning, ladies and gentlemen. I might as well get started with the first talker today. It's Stephen Kelly talking about CMake with Qt.
Good morning. Can everybody hear me? I'm coming through the speakers. Good. So, my name is Stephen Kelly. Again, I'm with KDAB, and I'm going to talk about CMake with Qt. I've been a Qt contributor for a long time, and I've been a CMake contributor for about a year, doing some of the core stuff now in CMake and improving it for the perspective of people using Qt. One thing I just want to clarify here is I'm not talking about replacing qmake with CMake to build Qt. That's a discussion for the Qt project, not for here. This is only about you guys using CMake to find Qt and use it to build your own applications in your own build systems. So I'm going to be talking about several different areas. We're interested in Qt 4 and Qt 5 and what's changing there with regard to the build system. And I'm going to be showing you some parts of qmake as well as some parts of CMake, just for comparison to see what they get right and what works well there and how things work in CMake as well. I will be talking about current CMake, how it works today, and also how it's going to work in the future, based on the changes that I'm making there. So why you would use CMake instead of qmake? Well, there's a bunch of reasons. CMake has a system of finding dependencies which qmake doesn't really have. You can still use package config if you're using qmake, but CMake has its own system of an extensive way of finding external libraries and header files and all external dependencies. Also, if you're going to provide shared libraries for other people to use, it's useful to use CMake because you get a way to install configuration files so that anybody else using CMake will be able to have a lot of control over how they use your package. You'll be able to specify what libraries are there, what includes should be used, what include directories should be used, and what compile definitions should be used. So in that sense, it's similar to how package config works, but more powerful. We'll be looking into that too. There's also a lot of platform independence that you get with CMake. You can do compile checks and configure checks at CMake time so that you can find out, does this include that I want to include in my program actually exist? Or do variadic templates work in the compiler that the person is now trying to build my program with? That's something that you can't do with qmake. It's actually a problem in the Qt CI system. We found that we couldn't turn on a test configuration in the Qt CI for C++11 because qmake doesn't test at qmake time whether C++11 is actually available. So it was failing in the CI, and we didn't get that patch in to the repo. It's also extendable with your own macros and functions, and it scales very well. There's also a bunch of related tools. If you're using CMake, it's also very easy to use cpack, ctest, and cdash. cpack is a tool that you can use to create your own packages. You can create tarballs, Debian packages, and RPM packages. There's also ctest, which is a test driver. It works very well with the Qt test system. With a couple of extra macros, you can set up this system so that it will run your Qt unit tests and tell you which ones failed, which one passed. And you can also group them in several different ways. cdash then is a server-side system mostly, and also a client that you use to upload test results as a result of executing your tests with ctest. CMake itself uses that system, and if you look at the CMake dashboard. I guess this might be zoomable. Well, looks like something's wrong with my browser. Well, what I wanted to show there was just that the C-dash system collects results from lots of different machines actually running the unit test for CMake. Different operating systems, different configurations, different availability of dependencies, etc. So it's much easier to use those tools if you're using CMake. You can use them even if you're not using CMake. We have a project where we're using CPAC together with QMake, so that still works. These tools are independent enough that they can be used on their own, but they integrate well with CMake. So what CMake is responsible for is the configuration, first of all, of our build system, and then generation of our build system. CMake is not a build system itself. Instead, it generates build systems for you. It can generate Makefile-based build systems, Ninja-based build systems, Visual Studio, all versions, and XCode build systems. So once it has done that, once it's generated the Makefiles or the project files for you, you're then responsible to run make or to execute the thing in Visual Studio in order to generate any files that need to be generated, compile them, and link them. So CMake is only responsible for the generate step. So how does CMake find dependencies? If you've used CMake before, can I get a show of hands? Who has used CMake before? About half of you. So you've used it probably to find Qt if you're at this conference, and you will have done something a little bit like this. So you find package Qt4, you include the directories that Qt says you're supposed to use, you add the compile definitions that Qt says you're supposed to use, and then when you write your own executable, so this is just a main hello world application, so no multiple files, nothing to mock, anything like that. Just imagine it as showing a message box or so. And then you link against the Qt core and the Qt GUI libraries. Win32 here is a special marker in CMake which determines on Windows whether you're going to create a console application or a GUI application. So we're going to use the Win32 API. In Qt5, you can do the exact same thing, well, a very similar thing, without changing too much. Because Qt has all gone modularized, so has all the CMake files for it. We're now generating inside of the Qt install tree a CMake file so that we can use find package Qt5 widgets or Qt5 core or Qt5 GUI or Qt5 declarative. And then once we've done that, we include the directories for it again, we set the definitions for it, but we also have to set position independent code to on. This is a new requirement in Qt5 that you need to compile with -fpic. If you want to know why, you'll have to talk to Tiago or read all of his blogs about it. It's very complicated stuff about linking and relocations and all that kind of thing. And then it continues as before, add executable and target link libraries. One change down here at the bottom is when I call target link libraries, I only need to link to the leaf, you know. We know that Qt5 widgets depends on Qt5 GUI and Qt5 core, so I don't need to link explicitly to those. Instead, this variable knows that it has those dependencies. With the Qt4 stuff, I don't think it knows its dependencies, so we have to list them explicitly. So that's how you can do a straight port from, you know, a CMake version today from Qt4 to Qt5. In QMake, it's a lot simpler. You've only got a couple of lines. If you're doing a Qt4 project, it's only 2 lines that you would have here, the target and the sources. Qt plus equals widgets is a new requirement in QMake. By default, QMake links you against Qt core and Qt GUI. So if you want to link against Qt widgets, you have to state that explicitly. So can we do better with CMake too? Looking again at what we have today, this is what we're going to have tomorrow for some definition of tomorrow. Newer versions of CMake are getting smarter. They're understanding that if I need to link against Qt5 widgets, of course I need to compile against it too. And that means that I'm going to need the include directories that it says that it needs, and I'm going to have to use the compile definitions that it says that it needs. So we're going object-oriented. This Qt5 : widgets is what we call an imported target. I'll be looking into that a little bit more later. But that's an object in CMake terms, the best kind of object that we have, which has properties which say if you're linking against this, you need to have /user/include /Qt5 in your include directories, and you need user include Qt core and user include Qt GUI, etc. But because CMake is a separate tool to Qt, and because it has its own release schedule and its own compatibilities and everything like that, we can also backport the same ideas to the Qt4 system. So sometime in 2013, you're going to get a new CMake on your system where you can simplify your Qt4-based build CMake files a lot. You won't have to specify the include directories or compile definitions for them anymore. Oh, yeah. So another thing about this Win32, those of you who've used CMake before, well, and if you've used CMake on Windows in particular, you will know that you also need to link to a qtmain.lib on Windows if you're making a GUI application, so that it provides the create main function, or the correct main function. It's a small static library that you need to link to on Windows. Usually you need to link to that explicitly, but also in the future you won't need to link to that explicitly. It'll be linked in automatically. And it's not just Qt that's going to be affected by this. Last week I was talking to some guys at another conference who do a lot of Boost, and you're going to be able to do the exact same thing with Boost and with every other dependency of CMake. It'll take a little bit of work from all of those projects and from CMake upstream, but you will be able to use target link libraries with any Boost library without, again, specifying include directories or compile definitions for it. Boost MPL, that's a header-only library, and we're calling it with target link libraries. But it's really just an implementation detail that that's a header-only library. We don't really care. But the problem is that this name is not very suitable anymore. So we might add a new function called target use targets in order to specify which targets I'm actually depending on, and CMake will figure out how to use that then. So the only problem there is with the name of the function. It's just not very good anymore because it's doing so many more things. One of the advantages of this is that it solves the qtestlib problem. If any of you have made unit tests before with CMake and Qt, especially if you've created both core and GUI unit tests in the same build system, you will have had a linking problem. And hopefully I can show that on my Kate editor. So everybody can see this? What I have here is a regular CMake build system. I'm finding Qt core. I'm setting Automoc to on. I'll get to that later. I'm telling Qt that I want it to execute mock automatically. I'm including the use file. That's a simple way to add the include directories and the compile definitions at once. And then I'm adding two executables. One of them is a GUI test. The other one is a core test. I'm using the same main CPP file just because it's a dummy file. And one of the tests I link to the Qt test and to the Qt GUI library. The other one I only link to the Qt test library. So the way that I use that as normal is run CMake on the directory that contains the CMake list file. And then afterwards I run make. And of course, being a demo, it fails, but it's actually failing deliberately. It's telling me that it's got undefined references to QWidget, QApplication, all those things that are in the Qt GUI library. It's not actually linking to, but for some reason it wants to. So what's going on there is that it's failing to link the core test. If I comment that one out, it'll work just fine. So I'll look a little bit into that main.cpp. It's also extremely simple. The most basic Qt unit test you can have: include the Qt test header, create a QObject subclass, create a private slot which gets executed at test time, and a dummy test. Of course, also include the mock file. This QTest main is actually a macro. It's defined in the QTest header, but it actually has two definitions. One of them is here, the other one is here. There's actually a preprocessor condition, if def Qt GUI lib. So one of these uses QApplication. That's the one that you use if you have Qt GUI lib defined. The other one uses Qt core application. That's the one that you use if you're not linking against Qt core. Or if you don't have Qt GUI lib defined. So the Qt4 CMake files are a bit too helpful, I guess, in which compile definitions it adds to your compile line. This Qt use file actually adds any compile definitions which were specified here when you called find package. So because I said that I want Qt test and Qt GUI, because of course I have a GUI test here as well, it defines Qt GUI lib for me. But then the core test doesn't compile anymore. So because I've gone object orientated with the new CMake instead of directory orientated as this is, I solved that problem. We're no longer going to hit the QTestLib problem anymore. So how does finding dependencies actually work? You can find many different kinds of dependencies. You can find libraries, and you can find packages of executables. CMake ships with a lot of ways to find library dependencies and executable dependencies. if you find a library, it'll tell you which libraries are actually in there, which header directories do you need to use in order to find header files, which defines do you need to use, what is the version of this package. If you find an executable package such as Squish, you'll get the executables and you'll get some macros in order to use those executables. This, by the way, will work a lot better in CMake 2.8.11, which is going to be released in January. Alex Norndorf, who's giving a talk after mine in another room, has got a lot to say about this. So there's actually two systems that can be used to find dependencies with CMake. One of them is with find files. There'll either be, you'll use find files shipped with CMake, or you'll write one yourself in order to look in the various places for libraries and for includes. On all the different Linux distributions, they put includes and libraries in lots of different places. They call QMake different things. Some distros call it qmake-qt4, some of them call it qmake-qt4. And the find qt4.cmake file is aware of all of those differences. And it looks in every place to find qmake and then asks qmake for, so where are the includes and where are the makespec files, etc. So the not part of upstream point is that we wouldn't ship the find qt4.cmake file with qt4. And the reason for that is because the find files are like treasure maps, and you wouldn't put the treasure maps beside the treasure. So the person wanting to find qt4 has to have the find qt4.cmake, so it's more of a documentation thing. You wouldn't ship it with qt4. However, there is also another type of way to find packages with CMake, that is config files. And this is what we have with Qt5. I've written a lot of config files, and we're shipping them with CMake. And it's aware of everything that you passed on the configure command line when you built Qt5. It's aware of where everything was installed already. And CMake will be able to find it if you set the right environment variable. Other projects also do the same thing. If you look on your system, you'll find a pulse audio config.cmake file. And that means that you're able to find the pulse audio package without needing to write or find on the internet a find pulseaudio.cmake. So that's something that we ship as part of upstream. CMake actually uses slightly different algorithms to find to use either the find modules or the config files. So once you've found your dependencies, a lot of the time you're going to want to generate code before you start compiling and linking. In Qt, that means mocking commonly, and it also means running UIC. The find Qt4 package in CMake ships with a bunch of macros to make that easy. The Qt4 wrap CPP macro is for mocking. The Qt4 wrap UI macro is for UIC. In Qt5, we have some equivalent macros, Qt5 wrap CPP, etc. So there's a lot of source compatibility kept there. So you call those macros and populate some variables with the result. And then when you call add library, you use those results again. So that'll compile them into your library. Again, in QMake, it's similar. You've got to list out the headers, same way as I had to list out the headers for mocking. And then QMake will take care of compiling that into the library. But we can do better now in CMake. In CMake 2.8.6, a feature was added to automatically execute mock from CMake. It got a lot of bug fixes and improvements in CMake 2.8.8, so that's the one that I would recommend using as a minimum by now. And if you use that version and you set Automoc to true, there's no need anymore to use the Qt 4 or 5 wrap CPP macros. The way that you use the Automoc feature is that you either include the mock file in the CPP file. So inside of mywidget.cpp, maybe at the bottom I would write mock_mywidget.cpp. But even if you don't do that, it still works. So you can have clean C++ files without including the mock file at the end. And what CMake will actually do then is it will concatenate all the mock files together for a library, compile them as one translation unit, and then link that into the library. So everything works very automatically and implicitly and nicely. What it actually does is it looks for the QObject macro in header files and in CPP files. So the way that you use that is you either set the Automoc property on the target that you want to have Automoc available on. You can set it to on or true or any other true variable after the fact. So after creating the library, after calling add library, I can set a property on it. But I can also make a global setting for that. If I set CMake Automoc on, all following libraries and executables will have their Automoc property set to on automatically. So if you've got large, complicated systems like we do in KDE, we'll be using it like this so that we can set it to on somewhere up high and then forget about it. There is still this wrap UI, and we have to specify UI files here. There's been a couple of requests for an auto UIC feature. I think that could work, actually. Nobody's working on it, but I think conceptually we should be able to do it, so maybe someday. This could get even easier. Also, in terms of code generation, something that you can do with CMake is generate your QM files. Those are translation files that you ship with your application or library. You can generate those at CMake time, well, at build time really, so that you can ship them. I don't think QMake can actually do this. So if you're using QMake, you'd have to manually run lupdate and lrelease, and then get those into your package afterward, and you'd have an external script for doing all of that. But because we're able to have CMake macros for this, we can use cpack to automatically package in the result as well. So it helps our packaging system to be able to do this in our build system. Also on the topic of code generation, there's ways to create dbus files from CMake. So given a header file, I'm sure some of you have used dbus before. It's an inter-process communication system available on Linux. It can also be run on Windows and Mac, but it's not automatically available there. It's most commonly used on Windows, on Linux. And how it works is you create XML definitions of an interface between different processes. Qt has a tool called QtDB12 CPP to XML, which parses header files and generates those XML interfaces. So we can have a dbus macro to automatically invoke the tool and generate the XML interface. And there's a complementary macro which uses the XML interface to create a C++ interface to the external processes. So these are, again, features that are not available in QMake as far as I know, at least not in public API. And they really simplify the use of dbus, at least enabling the use of dbus in your build system. I mentioned platform independence before as well. One of the significant points in this is that CMake allows you to run a lot of checks to see, does the limits.h include file actually exist on my system? You know, there's a lot of systems where that might not be true, or other header files which might not exist and you have to check for when you're generating the build system. There's also other macros to check a piece of source code actually compiles. Again, this PIC one is just something that showed up in Qt5 as something that's necessary now. It's compiling against Qt5 will fail unless you have fpic defined. So any arbitrary piece of C++ code can be put in here and used with this macro, and CMake will invoke the right compiler with the right flags on every platform to see if that thing actually compiles. So if you want to create dependencies for somebody else to use, you probably want to make it as easy as I've made it for Qt5, so that they don't need to use the include directories command, and they don't need to use the add compile definitions command. And you also don't want them to have to write a find mypackage.cmake file. You want to provide a config file. So the way that you do that is, if you are the author of mylib, you're going to have some install commands to install the library itself and to install headers. And if you add a component to the install command to say, give a name to what you want to export, at the end you can call install again with some export, and that will generate most of a config file for you. It actually generates a targets file, which we'll be looking into just in a moment. So now that we've used this install export command, we can write a config file very easily by including the result of it. This is the same as what I exported to. And then any other macros that I ship with my library. And now downstreams will be able to simply call find package with mylib. They won't need to find or search for a find mylib.cmake because we installed this mylib config.cmake file. And they'll be able to use it just the same as we can use Qt5. Simply link against mylib or other lib without having to specify the includes or the defines. So what it actually generates in the targets file is what we call imported targets. So these are special kind of libraries and executables that CMake has, which are kind of symbolic. Usually when you call add library in CMake, that means I want to build this library. But imported targets are things which are already built and available somewhere on the file system. And we need to specify the location that it already exists. So if you ever look into the config files that ship with Qt5, you'll see a lot of stuff like this, where I'm specifying a target and giving it a location of where the file actually is. It's automatically generated at configure time by QMake when you build Qt5, and when packagers package Qt5. But because this thing is it's an object, it can have other properties too. Apart from just location, we can also specify interface include directories. This is a special property which CMake is aware of, and what it means is anything that links against Qt5 GUI is going to look up the interface include directories property and see which include directories should be used. And that contains Qt5 GUI include there, and it also includes a special syntax to say, I also need to include the include dirs of Qt5 core. In reality, this syntax is a little bit more complicated, but let's pretend it's simple. So again, this is features that are going to become available next year. I stopped putting that in my slides, but this is CMake that you'll be able to use in 2013. So onto the Qt main lib problem. In QMake, it's automatically linked in, and if you want to create a real console application with QMake, you need to tell QMake to do the opposite. You need to, oh, that should be a plus equals. You need to say config equals console or so, and that will make QMake not link in the Qt main.lib library. If you're using Qt4, you need to use target link libraries with this Qt main libs thing. In Qt5, you no longer need to do that. CMake will automatically link it in if you need it. It knows whether you need it or not, depending on whether you specify this Win32 property. And that's also done on the Qt5 GUI target. There's again a special property called the interface link libraries, and that one knows what each library depends on. So Qt5 GUI depends on Qt5 core. And if the Win32 executable property is set, that's what we set when we use Win32 and add executable, then also link to Qt5 Win main. So I'm showing you this because this is a new sub-language in CMake. It's a declarative syntax. It's executed at generate time. And you can have dependencies between different projects. You can define dependencies between different targets. And the way that you're going to be using that, possibly, or one way that you could use it, is if your executable can make use of the Qt5 test library. For example, if you compile it in a debug build, you can conditionally link to Qt5 test library, depending on whether the configuration is debug or not. So if you build cool app in release mode, it's not going to link against Qt5 test, but if you build it in debug mode, it will link against it, and you can use the QSignal spy, or you can use the logging facilities that are in that library in cool app. And you might be thinking, I've done configuration specific stuff in CMake before. All I need to do is check the CMake build type. But actually that only works for the CMake Makefile generator. When CMake is generating Visual Studio project files and XCode project files, it actually generates all configurations at once. So the CMake build type is then useless to you. So again, this is a piece of the declarative language that you might see in the future when you're using CMake. Another way you could use it is if we're building the debug configuration, we can include the Valgrind include path, and then we can simply include valgrind.h and use it. This already works with CMake 2.10, which was released about 2 weeks ago. 2.8.10, sorry. So these features are being added incrementally along multiple releases. So CMake is going object-oriented, and it's going kind of declarative. That might ring a bell for some of you. About last year, the Qt guys started talking about cubes. This is QBS, they pronounce it cubes. It's a new build system which is based on QML. And whereas CMake was only responsible for the configure and generate steps, Qubes is responsible for everything. So it also replaces the use of Make, and it replaces the use of Visual Studio to build projects, and it replaces the use of XCode to build projects. And it uses QML. And so I thought, well, can we do something similar with CMake as well? And I did a little bit of prototyping to see what a CMake language, or a CMake file looked like if we had QML as the language instead of the regular CMake language. So this actually works. I'll execute it in a moment, but first I'll talk you through it. I've replaced all the regular CMake commands with QML properties and QML elements. So whereas you would call the CMake project command in a CMake list file, now that's a QML element. And if I want to build a CMake QML executable, rather than calling add executable, that's again a QML element of type executable. These are the files that need to be compiled in order to build that executable. And it depends on Qt5QML and CMakeLib. This is actually the build file to build itself, to build the tool that's going to execute this build system. So the first thing I need to do in my demo is build the new tool, build this CMake-QML executable. And that did not succeed. I wonder why. Oh dear. This worked just about an hour ago, of course. So I guess we won't be demonstrating that today. That is just a little hack that I did on my education time, self-education time that we get in KDAP to spend on creative and innovative things. But yeah, it's a nice idea. I mean, we like the idea of using QML as a build system. So that is actually all I have. So if any of you guys have any questions, I'll be happy to answer them. And if you have any other build system that you use which has some cool features, I'm interested in that too. Recently I've been looking at the Boost build system called Boost Build, and it already has a lot of the features that I'm now adding to CMake for that object-oriented or target-oriented use case. So yeah, if any of you guys have questions, just put up your hand and speak into the microphone.
Okay, I'd like to ask whether it's also possible to avoid the automatic linkage to Qt main, because I happened to have the situation when I had to implement my own win main function, and then I would like to avoid this conflict of the two main functions being defined.
Yeah. So I've encountered projects like that as well at customers where they don't link to the qtmain.lib, but they define their own winmain function. So I think it's a valid use case and it will work, yeah. You will set, Qt5 no winmain library or so, and it won't automatically link in.
Okay. And another thing was this fpic thing. I encountered this problem when using CMake 289, and actually this version of CMake had a bug, and they fixed it in 2.8.10, so they couldn't even build VTK with their own build tool.
No.
And in 2.8.10 it has been fixed.
With PIC.
Yes, so I wonder, do I still need that for the main executable, or don't I?
You do, yeah. I'm not familiar with the CMake bug that you're talking about, but yeah. When using Qt5, you do need to use set CMake position independent code to on, otherwise it won't compile.
Okay, it was connected with shared libraries, which we.
Oh yes, and, I think I saw that bug actually. Yeah. For executables, there's no change. Yeah.
Okay. Thank you.
Sure.
Hi. I'm wondering how it's supposed to work with these decentral compile definitions. So if I use Qt and boost, and one sets a compile definition fpic somewhere and the other don't, and I include header files from both in my application, how do I have control on that aspect?
Well, you need to make sure that you can use both libraries. So that's sort of something that's independent of CMake. If Qt requires that you use fpic and some boost library requires that you do not use fpic, then no build system will be able to resolve that for you. What will actually happen is CMake will give you an error at generate time. It'll say this library requires fpic and that library requires that you don't use it, so there's a conflict here. You need to resolve that by either recompiling your Qt to not require fpic, or reconfigure your boost. Does that answer the question? Or?
Yeah, is there additional an option visible to see which flags are used? It's particularly on Windows quite hard to get a track what build flags are active at one point in time.
Yeah. There is actually. There's a property on. Well, actually, no, there isn't. The way that I usually debug things like that is I build them with the Makefile generator, and I use make verbose equals 1, and that will print to the command line the actual flags being used. On Windows, I'm not really sure. There is the nmake generator there, so you could do something similar, but I'm not familiar enough with Visual Studio project files to know how you would see it there.
Okay, thank you.
Thank you.
Hello.
Hello.
Is there some more integration coming also for QML inside CMake? Like if you're working with QML files in Qt Creator, for example, then I always make a custom target which never gets built to load my QML files inside of Qt Creator. So is there another option coming that you can add your QML files to your project somewhere, that they also show up in the project and not get built?
I think there is a way to do that. There's Yeah, when we call add executable, we can specify some other files, and that's where you would list the QML files. I can probably show you that after.
Yeah. And that way they not get built inside executable, they're just listed in
They don't
project.
get built, but they're dependencies first of all, so if they change, the thing will get rebuilt. And also they'll show up as part of the project in the visual IDEs, in the GUI IDEs. Some more questions?
Hi. Let's assume my project has its own Qt library and include files. So I'm not using Qt that is installed on the system. Can I tell find package to search for my own Qt installation, or?
You can when you invoke CMake. You can either set an environment variable, or you can pass a command line argument to CMake. So you can set the CMake prefix path environment variable, and it will look in the path that you specified. And similarly, you can call CMake-d CMake prefix path equals the path, and it will use that path.
Okay, thanks.
Sure.
So hello.
Hello.
Where's the best place to get more information on these topics?
Well, there's documentation shipped with CMake. There's also the book Mastering CMake. There's also a wiki, and there's lots of other projects using it on the internet. There isn't really, I guess the best resource is the book Mastering CMake, but of course you need to buy that. The documentation is also being improved always over time. But if you can't figure out something from the documentation, you can always ask the CMake users mailing list. That's a very helpful mailing list. You'll always get answers there.
Is all the Qt5 stuff also documented on the CMake?
Yes, it is. That's actually documented in Qt itself. So if I have internet, I can probably show you. So in Assistant, there's a new CMake manual. It gives you some snippets that you need to use in order to use CMake, and also it how to use Automoc and how to use FPIC and everything like that. So that'll also be maintained by myself, and I'll keep that up to date. Okay, if there's no more questions, then I think that's it. Thanks for coming and for paying a lot of attention to my talk, and hope you learned something about CMake.